Testing. Testing 1, 2, 3. Mic check. Testing 1, 2, 3. Hello, hello, hello. Mic check. Testing 1, 2, 3. The audio is a little low. Mic check. Testing 1, 2, 3. The audio is a little low. Alright, mic check. Testing 1, 2, 3. The audio is a little low. Alright, mic check. Testing 1, 2, 3. Alright, well, welcome back, everyone. Thank you for joining us. We've actually had a few responses from some viewers, so I actually appreciate you working some of these problems out with me and even correcting me when I'm wrong. This is still a learning process, and that's what we're here to do, to learn to get better. And so today, we're actually going to switch it up a little bit and just start trying to attempt some problems from sample exam 1. And so we'll begin from the first problem. So we're working problems out from Conquering Physics GRE. And the first problem is from sample exam 1. It's stated, a centrifuge can be used to simulate large gravitational forces. Consider a centrifuge consisting of an arm of length 4 meters, rotating about a fixed pivot at a constant speed. What must the speed be to simulate a gravitational acceleration of 9 g's? So what's interesting is that this is kind of the setup that they have. You basically have a center point that's rotating. You have some type of bed or some type of seat where a person could sit in with a counterbalance to make sure this thing just doesn't wobble out of existence. And you can put somebody in a little chair, and they're sitting down on it. And you could think of like an astronaut or some type of air pilot training, and this thing's gonna get spun around, right? And it's getting spun around with such a velocity, and based on you can think of it like a centrifugal force. This point, in order to follow along this trajectory of a circle, there must be an acceleration or force inward. And so this is how gravity is simulated. And so there's a inherent force here. And so if you are a body in here, your acceleration, if the velocity or speed is constant, is equal to v squared over r. And so we were given here that this radius is 4 meters. We'll keep it as r for now, just so we can keep it general, so we can see this. And the question is asking, if we were to have basically have this spinning, what does this v have to equal in order for your acceleration to be equal to 9 g's, which is a form of acceleration. So a g is a gravitational unit, which is approximately 9.8 meters per second squared. And this is an acceleration. This is the gravity you feel every single day. Imagine if you just all of a sudden gained 10 times your weight. That's how it would feel like. And that's what is meant by these g's. Okay. And so in order to solve this, again, one thing I always mention is force body diagrams or energy, and this will help out a lot. In this case, the sum of the forces, but it's really just this A term. It's equal to MA, and it's equal to MV squared over R. And so we really just have to work this. And so what they're saying is this A, we want it to be 9 G's, right? So we could just have this 9G substituted for this. We can cancel out both M's if we just have this. 9 G's is equal to V squared over R, or in this case, we'll just already plug it in 4 meters. Okay, and then if we were to multiply both sides by 4 meters, we're going to have 36 meters times G is equal to V squared. And so here we take the derivative of both sides. or my apologies, we take the square root of both sides. What are we left with? We're left with v is equal to, so in here, 36, take the square root of it, you have 4 times 9, so this would end up being 2 times 3, or 6. 6 times, so hold up, I just want to make sure that I got my units squared away. Okay, so for our r, that is units of meters. And since we're taking the square root of this, oh yeah, so this is gonna, now with this we have units of, um, this g is m over s squared, as denoted up here. And so this meters, we're gonna have meters. So we're actually gonna have 6, which is the square root of 36, times the square root of meters squared over second squared, and then over, technically it's 9.8, the square root of this as well. But we're just going to leave this as g, so just thinking more of the magnitude of g. So this is going to be 6. This is going to be the square root of the magnitude of g, so just a number, times meters per second. And so of the answer responses that we have all of them have units of g m over s, but the responses were 2, 3, 6, 18, 36. And so we just solved it out at 6. So this would be C. Neato. And that's a problem for today. We'll continue to solve a problem a day, and maybe at some point we'll just try to do a run and just do a bunch of them. But for now, that is all. Thank you for being patient with me, and I look forward to working out some more problems with y'all. Take care and have a good night.